All right, on 111 from 7.5, same kind of idea here. On the left side, we have a triple angle, all right, 3 beta as our angle. And then with each of these, we only have beta. So much like the number 97, it's the only way we're going to really be able to work with this is actually break down the left side so we can get the angles to become beta. So it's easier for us to make this become beta as opposed to these 3 items to become 3 beta. All right. So that's one unique aspect with those multiple angle examples, all right, with verification. So we can break down the cosine of 3 beta into the cosine of 2 beta plus beta, all right? And that would once again be using the sum formula for cosine, all right? So if we apply our sum formula for cosine, once again, that's going to be cosine, cosine, sine, sine, right? All right, so we have our value of u and v, so this will be the cosine of 2 beta times the cosine of beta. All right, u and v plugged in there, and then will we do plus or minus? Minus. Remember, the cosine is the composite, right? Yeah. All right, and then we go sine 2 beta, sine beta. All right? Any questions? What's up?
So why did you choose addition for the cosine? Like, why couldn't we do 4b minus?
Because we have more to work with 2 beta and beta as opposed to 4. Okay, we have some identities that involve 2 beta. Or yeah, and we want to break it down to be beta, right? So we'll be able to work with this, with the cosine of 2 beta and the sine of 2 beta. All right. All right. So as I look at this, things that we want to get, we need a cosine cubed beta, and we need this minus 3 sine beta cosine beta, which is kind of funky. All right. So we can use substitution with the sine 2 beta. All right. We can use the double angle formula for sine. So if we go ahead and do that, we will have minus, if we plug in the double angle formula for sine, that's 2 sine beta cosine beta, right? Okay. But then we still have, I'll go ahead and put that in a different color. So I'll put that in blue. So minus 2 sine beta cosine beta. But then we still have that other sine beta left over, correct? And if I just work with that piece overall, we have a sine beta and a sine beta. So that will be minus 2 sine squared beta cosine beta, right? And that's good for that because we're getting it to look more like the right side that we were dealing with, right? This is pretty close to the same structure as what we have there, except down here we have minus 2 and here we have minus 3. So we still have to attain another one of those. All right, but that at least gets us closer to what we want to get to. So I worked with that part. That's pretty good. All right, now we need to try to work with this piece. All right. So we have to ask ourselves, what do we want to plug into the cosine of 2 beta? All right. We have 3 options, correct, for the cosine double angle formula. All right. If we look at those, 3 different options. All right. So you would pick one of those. All right. You may want to try to think a little bit forward in terms of what that could possibly be. All right. But if one of them didn't work, then you would persevere and go back and try the other. And if that one didn't work, then you try the other one. Okay, so I'm just going to start at the top of the list. All right. And to the best of my knowledge, this should work, I believe. So we're going to go ahead and replace cosine 2 beta with cosine squared beta minus sine squared beta. And and that will still be multiplied by the cosine of beta. All right. One reason why I was confident that I should choose the cosine squared beta minus sine squared beta is we talked about how we still need another one of these, right? And the only place I'm going to get that from is this portion here. So I needed a sine to be involved, but I also needed some cosines because I got to get a cosine cubed out of this, right? So with this portion right here, I need to get another one of these and cosine cubed. So if we go ahead and work with that, we can do a little distribution, right? Cosine beta times cosine squared beta would be cosine cubed beta. That's good news, yes. We need one of those. And then we would have minus, when we distribute here, minus sine squared beta, cosine beta. We needed another one of those, right? Well, we found it now, so that is great. And now we can do a little CLT around our terms. So that gives us cosine cubed beta minus, and if we combine those two terms, now we have minus 3 sine squared beta cosine beta. We can combine those because they have the same amount of sines and cosines of beta. So we can condense that down to that. And now this is verified, all right, because this is equivalent to that. So at the end, you would write out that they equal one another and stop.